Gabe VanSolkema. I'm an application developer here at Configura. I've been here for just over 3 years now. Disclaimer, the first 2 years I was here, I was treated as a subhuman due to my intern status. um, about a year and a half ago. So yeah, since then I've been a full-time application developer, and I've spent the bulk of my time has been with Office extensions, developing Office extensions. I spent some time in Fika if you've had a chance to check that out. But yeah, just a little bit about myself. Nice to meet you all. Some familiar faces, but yeah. And today I will be talking about bounds and snapper references. And to preface, honestly, snapper refs are not ready. As of 2 days ago, these were cut out of the presentation due to the fact that they are still in flux. So they are still being programmed. As of 2 days ago, the constructor for this changed and all of their fields changed as well. So they do not currently play nicely with save drawings, favorites, copy system. So if you're using those currently, make sure you are accounting for these things if you haven't noticed issues already. And if not, I would hold off on using these until at least 10.0, just because they are still in flux, they're still in development, and so it's best not to use them at this point. But bounds, there's a lot to talk about bounds. It's great. I have more time to talk about it, and yeah, let's get to it. So we're gonna just about what are bounds, why do we have them, how are they used, the different types of bounds that we can use, how to leverage those bounds, and then probably most importantly, how can we optimize these bounds? They are crucial to what we are doing with space interactions. Whether you're dragging things around, clicking on things, hovering over things, we need our bounds to be efficient and fast, and most likely you're going to want to cache them. So we'll talk about all these things. Because I have more time to talk about bounds, I can actually talk about really why we have them and get into the nitty-gritty of our graphics and how we deal with space. So here I have a triangle mesh, sphere wireframe, and as you can see, the sphere is made up of a collection of triangles, different shapes. Triangles are perfect because they are the simplest shape, and when you use triangles together, you can create more complex shapes. So this is a triangle mesh. The vertices that you see on the corners of the triangles, these are actually reused, so we don't necessarily, I'm going to move over here. Let's say you have this guy right here. You can see there's 6 or 7 triangles around that one vertice. We actually just use that one vertice as opposed to duplicating it over and over again when calculating our triangles. That's a little bit of a side note, but you should know that our graphics are made up of triangle meshes. And as you add more graphics to the drawing, you're going to have way more triangles. Your models and your drawn graphics are going to potentially contain tens of thousands of triangles. So you want to be aware of that. And that's why we have real-time versus render. We cannot work with all of these triangles all at the same time because there's just too many of them. And so when we work in real time, we don't have super high resolution graphics. We have sort of like dumbed down graphics so that things we can operate smoothly. The user can operate smoothly, designers as well as developers, because we do not want lag while we are designing and working with the software, working with the space. So yeah, as you can imagine, if you have a space with thousands of snappers, lots of models, all of a sudden you have lots and lots and lots of triangles. And so we have to break up the space somehow. Otherwise, every single time you dragged your mouse around and hovered over something, we'd have to check all of the triangles in the drawing to see if you're hovering over a specific thing. And so that's where the BSP comes in. And I added this picture because it's gibberish, and I thought it was funny. But binary space partitioning is what the BSP stands for, and that's binary, of course. So, but yeah, the BSP breaks down the space into nodes, which are stored in a tree, and this should be relatively simple to you guys. A BSP node has 2 fields on it, which are 2 more BSP nodes, and that's how a tree happens, right? So you have a BSP node, and it says, well, I have a left node and a right node, and so on, and from there it can branch out and make a tree. But the main purpose of the BSP is to break down the space and allow for things to be calculated much more efficiently. So I'm actually going to just show you guys what the BSP looks like. Turn on the debug. Let's see. Shift tab. Ooh. Did you lose me? Maybe. Shift F5. Okay, so
what are you trying to do?
Switch to Emacs.
Yep. Okay. Back to presentation.
Okay. Nice.
Try it again.
Okay. I wonder if I can actually just Shift Tab now. Alt Tab, sorry. Bummer. Shift F.
Duplicating that replicating?
I believe so. Duplicate slideshow.
I mean, you
Sorry. Minor technical issue. Duplicate.
Yep, that's right. Try just hitting extend or Emacs. Sorry.
Oh. Weird.
PowerPoint.
Okay, so can you all see the code? So we were talking about BSP. I'm just going to show you guys. I can describe it all I want, but I think I'm a visual person, so showing you guys visually what the BSP is doing as we add snappers to the space is probably best. I'm just going to go into BSP. And I'm going to turn this guy, this flag right here, I'm just going to turn that guy to true. Pile, we'll throw CUT up. Okay, so here's space. I've got a little snowman snapper. If I refresh now, you're going to see one BSP node. We don't need more than one. There's just one snapper drawing, right? So if we start adding snappers, you're going to see eventually the BSP decides, hey, I need to break up myself because there's a lot of things going on. And once you've broken up, once the BSP is broken up into more than one node or as many nodes as it needs to be broken up into, it's able to calculate things much more efficiently. If you were to add something out here, for example, it'll just create a new one. But yeah, this is basically the BSP. The BSP is just boxes, basically, that contain graphics. And they relate directly with bounds, and I'll get to that. So. Yes, well, you're good. Okay, so let's see. Okay, cool. So bounds are very lightweight. They're simple. They actually are They're boxes, and those are values. Those are not like a class. They're not objects. So they're very simple. They're lightweight. They're efficient. They don't take up much space in memory. And they are used by the BSP to help break up space. So when you start adding snappers to space, the snappers have bounds, and the BSP says, what is your bound? Oh, I'm going to have to put you're in this node as opposed to this other node. And these help optimize space interaction. So yeah, I'll show you right now how that works. So if you have, let's add some more and make this a little more complicated. Okay, so if I am moving my mouse around in the drawing and I am aiming in here, right, you get a tooltip that's responsive, and that's because we're calculating things on the fly. The BSP is awesome because my mouse keeps sliding down. Sorry. The BSP is awesome because it can check this box first. And then from there, it can check the bounds of all these snappers. And so very quickly, without having to analyze all the triangles in a drawing, it can get to this snapper. So it says, are you in this bound? Is your mouse intersecting with this bound, or this BSP node, sorry. And yes, so let's check all the bounds within this BSP node. Are we intersecting with a bound? Yes. Okay, now let's analyze very specifically the triangles of this snapper. And you'll notice, this is kind of a niche situation, but if where'd my tooltip go? Well, it's not in the bound. So the bounds are very crucial for everything we do. If you've ran into issues with bounds, you probably know this. Okay, so now that you guys sort of know why bounds are important, why they help make our space much more efficient as we're interacting with it, let's go back into here. There are different types of bounds that you guys can leverage. So we have local bounds as well as just bounds. We have user bounds. We have connect bounds, component bounds. And then, of course, I want to include this just so you guys are aware. The BSP bound that it is using to calculate these things is actually basically concatenating the bound, the connect bound, the component bound, and saying, all of you together, what is your bound? So if you have one that extends a little bit further out, it'll take that into account. Yeah, so actually, I'm going to go back in code, show you guys some of this stuff down in snapper.cm. Let's see. So let's get to bounds. So there's actually a ton of methods down here. I don't know if you guys have explored, but there's tons of bounds methods. It's pretty simple. It's just grabbing the corners of your system local bound. And it's worth mentioning that by default, most of these things are pointing back to your system local bound. So you're seeing, the user local bound is pointing back to it, as well as the component local bound. The connect local bound, they all are pointing back to this system local bound, which basically, ignore this right now, we're going to talk about that soon. Basically, this is going to just call your local bound method. So if you've overridden this, your system local bound is going to call this, and likewise, all of your other bounds, your connect bound, your component bound, all of those are basically going to default back to your local bound. Now, if you're using abstracts and whatnot, there's usually, there's different ways in which bounds are being used. So be aware of that. Obviously, you're not extending directly off Snapper. But yes, this is how this works. So essentially, let's see, we go back here. Shift F. So I included the system local bound here. Probably should have included it earlier. But your user bound is that you want to modify. So usually your user bound is pointing to your local bound, as I said earlier. But if you want your user bound to look different, and your user bound is how the box visually appears around a snapper, you can override this, and this actually doesn't get called until you click on it, so there's no need to cache it. You can have your user bound just return the bound that you wish to see. So if you're trying to change your bound to make it look differently visually, use this bound, the user local bound, which I'll show you in a second. Use this one. Do not use your local bound method, because it should strictly be for clicking on the snapper and being able to interact with that snapper. If you want your user bound to sort of be displayed in some unique way, use this. The connect bound allows for the BSP bound to expand for connectors. I don't know if you've ever had issues with that. I talked to someone just before this presentation. If you have connectors that are residing outside of the bound, I've seen times where, and this is where I'm a little bit shaky, I've seen times where you can still click on those connectors, but I've also seen times where you cannot. So make sure if you have connectors outside of your bound, you can use this in order to include those in the bound so that they can be selectable as well. And it also affects connecting behavior. So snap all aligned is a good example. When you're dragging things around trying to connect, if you have modified your connect bound in some way, you may see some key connecting behavior. Or if you need your things to connect and you're not seeing them connect and you're confused, take a look at connect bound because there might be something wrong there. Your component bound, I'm not going to get super deep into components. They're really useful. I use them all the time. But these are basically prop objects that have graphics, well, may have graphics, may have data, may live on a snapper, but they might exist outside of the bounds of your snapper bounds. They might, like I have an example where I have 2 panel systems and I have components at the top that can merge, and the second they merge across, my panel bound, obviously, the component that's been merged is not inside the panel bound. So I have to use this in order to expand my bound sort of and include the component. And your components will need prick surfaces as well if you want them to be selectable. If you don't want your components to be selectable, who cares? So, and then of course the BSP bound, I want you guys to be aware of this. I would never change this method. This is a method that exists down in snapper.cm. I'll show you guys right now. Don't change this. Don't. This is not worth changing unless you are doing something very niche. Actually, you've been here for a while. Have you ever overridden that method? Okay, there you go. So, so yeah, let's see. Yeah, here it is. So you can see it's going to include your bound, which is your system rotated. Again, I didn't really touch on local bound versus bound. I did want to show you guys that in code. You're going to have a user local bound, and your user bound that isn't local is going to take your snapper's rotation and position and move it. So locally, your bound is, relative to your snapper. So if your snapper's here and you want your bound to encompass the snapper, you start at point 0, and you probably want to include your width and your depth and your height as the second point. After that, though, of course, the snapper exists in space, and so the user bound, the bound, I should say, takes that and rotates it and moves it to where it needs to be, which is why the BSP needs that, because it needs to know where it is in space. Yeah, I'm actually going to dive into Snowman. I got some code in here for you guys. Let's hop out here a little bit. So I'm just going to show you guys what happens when you mess with your user local bound. I'll even throw some trace in there. Yeah, I'm like, come on, stay here. There you go. So if I'm actually going to do one of these. I don't know if let's make a new drawing. Running out of hand room there. You guys see that pretty well? At least we can kind of have space, and we can have a drawing and our code in the same scope. So I made my user local bound 0.0 to 0.0, and naturally, this is now what the bound looks like. It's this little guy way down here. It's nothing. And it's worth noting that this is actually calculated based on your local bound. Now, if I click on the snapper, can I? Oh, maybe not. Hold up. Debug mode right now. So visually, you can just change it. So I mean, this is obviously a crazy, unique situation. I'm using spacebound, local bound. This should not be affecting that. Let's see what. Oh, there you go, man. Did anyone else catch that? Am I crazy? Yeah. Okay. It made sense. I was sitting there like my body. God, don't do 0.0. It makes no sense. You'll drive yourself crazy. Yeah. So this is actually, so I go here and here. So yes, when you click on it, this is selected. Makes sense. Um, the- so actually, yeah, let's get to the caching portion of this because I think that's important. Running out of time. All, all the time. Just I do. Because in my panel system, I have a lot of bounds. So like when I click on my panel, I have junction bounds and all sorts of things that work with the panel. And so when I click on it, it looks like there's just like 4 different boxes and they all are like slightly offset and it's just messy. So I actually move my local bound, my user local bound, I should say, so that it looks cleaner. It just looks like there's one box. I have them all so that they align nicely so that there aren't like 3 or 4 different boxes showing that are all slightly offset from another. That's just like I don't know. That's, I guess, it's always going to be an aesthetic thing. Like if you ever need to do it, it's purely for aesthetics. Um, this is the most important part of bounds aside from why they're important. Optimizing the bounds is what we need to be doing. So you can and you should be caching them. In talking with R&D and the people who are in charge of writing BSP code and whatnot, this simple box return is also very fast. So if you were to just return box 0.0 with depth height, you're probably fine. It's really fast, but I just want to show you guys how often this gets called. I'm throwing this in here right now so you can see. Got my crazy, oh, I'm using, turn that off. We'll talk about that in a sec. Get this guy. All right. So let's clear this output. We're at line 2 of, and watch that number go up. That's how many times yo from our local bound is being printed out right now. We're at almost 10,000 now. So this gets hit all the time. And that's why it's kind of important to cache it. Just because why? Like, if you can reference something and return it, you might as well. Let's see. And let's talk about caching in general. So there's actually something that you guys can use and leverage. It's just called use space cached bound. And if you return true here, it will automatically just return, or it'll automatically cache your bound in space for you. You don't have to keep track of that. You do need to invalidate your bound, maybe on a width, depth, or height change. You might want to call invalidate bound, make sure your bound is being invalidated, but all of the caching is done on space. You don't have to store your bound in a field on your snapper, which is kind of nice. And you can also use this protect bound change syntax, which is pretty cool. And what that does is basically, if you use your you use a protect bound change and you want to do a bunch of things inside of these inside of the scope of this, it's actually a syntax. So let's see if it's used anywhere in here. Oh, cool, it is. So if I go into this, we're gonna see. So gibberish looks like, but what I see is this. Okay, so it's gonna do all the code, and then afterwards it's gonna call invalidate bound. So protect bound change and invalidate bound are sort of interchangeable. The only reason you'd want to do protect bound change is probably if you're doing a lot of steps, things in between. Let's find it. I don't think it is. I don't think it is because I just looked. Oh, yeah, I didn't change this. So, yeah, no, this is false. So if you want to take advantage of this, if you're sick of caching your bounds, do it. Just turn this on, turn this flag on, and make sure you're invalidating your bound when you need to. Super handy. Space will take care of it for you. And yeah. Um,
What like what? I mean, why would you do it yourself if this? I know this didn't exist when we wrote a lot of our stuff. Like if I switch all my stuff over this, there's any reason to keep anything old do it yourself.
Probably not. I mean, you are sort of relying on space to do these things now, so you have to trust other thing, which, you know, trust is good. But actually, just see if they even make an invalidate bound. It doesn't. Let's see if Snowman does. Cool. Space, validate bound. See what it does. Okay, look at that. It's interacting with the BSP and validating the snapper's bound, Z. Space volumes. Not entirely sure what that is. Yeah, so I think if you do this, you're pretty safe. I mean, I don't see any reason why this wouldn't work. This is going directly to the BSP and invalidating the bound, so you should have, you should be able to do that. Now, if you do want to do if you are having your bound cached locally, I can show you how to do that as well. It's going to be Snowman bound. So I'm going to comment this stuff out and comment this in. Let's turn off that use space cache. Oh, that is okay. Cool. Here's my cache bound. Keep in mind this has to not be your box value. It has to be a box object. And this is because you don't have to do this, but it makes it pretty simple. When you need to update it, what you would do is you would call this method. You'd set it to null, and then you can just call local bound. So, Paul, you're squirming. I know. I didn't want to jump around. This is just for the sake of seeing like this all in one spot, sort of. Yes, this should be at the top, guys. Do we know where fields go, right? Don't start throwing fields everywhere. Yeah. Yeah, stay tuned for my syntax convention. Yeah, so if you want to cache your bound, this is a pretty simple way of doing it. You just check to see if you want to cache it locally. You just check to see if it exists because it's an object. It can be null, and if it does, you just grab the box value out of there. If not, you create it. So this works great because when you update it, you're setting it to null, and so of course this is going to fail. It's going to recreate it and reset it. So if you after your width changes, height, depth, you need to update this for whatever reason, this is a way you can do this locally efficiently. Okay, yeah, you can do that as well. It might not be. Yeah. So yeah. Oh, this is worth mentioning. Growing your bounds instead of calculating trivial differences. If you are checking to see if your bound is 10 inches or 12 inches using ifs, just get 12 inches and modify your user local bound. Because there's really no reason. If you get in a situation where you have this very complex thing where you're trying to calculate the bound on the fly, just return, what its biggest size could be and use your user local bound to, be more reactive because that'll only get called on the click. This is recommendation from someone in R&D who there's really not a huge hit to like making your bounds a little bit bigger, because the BSP and the bounds are already doing a lot to optimize things. So we just have to do the little bit on our end to cache them or make them efficient. So yeah, questions? Good question, and I think so. Yes, I believe so. Does anyone know? I can check. Yeah. Yeah. Components.